So this is a review of Unit 3 in Calculus. Unit 3 was chain rule, implicit differentiation. It also had inverses in it. So it's kind of like more derivatives is what Chapter 3 is about. So the first topic is definitely chain. You should be comfortable using the chain rule, either informally as the baby and the mama, or formally as, this is what the chain rule says, if f of x is equal to g of h of x, then the derivative is going to be the derivative of g evaluated at h of x times the derivative of h evaluated at x. The chain rule applies if you say the word of and the next word is not just a plain old x. The chain rule applies if you have like an exponential function, but the exponent is a function itself. So e to the 3x would be a chain rule. The chain rule does not apply when you have a product, when you have x times sine of x, for example. The next topic that we studied was implicit differentiation. Implicit differentiation is when you have a function, not a function, but a curve that has both x's and y's in it. And when you take the derivative of that, you treat y like a function because dx dx is 1, but dy dx is not 1. So everywhere you see a y, you're treating it the same way you would a function. So for example, this is not just x squared times y. This is that's a product rule that you're going to apply there. And this is a chain rule because you have a function to a power. I assume you probably want me to go through that just as an example. So I'll do that. So it would be 2x times y plus x squared times the derivative of y. And all of this is product rule plus 2y times dy dx, and all of this is chain rule, equals 0 because the derivative of a constant is 0. And then you solve for dy dx, so you'd have dy dx times x squared plus 2y equals 2x, and then you divide, so you have dy dx is equal to 2x times x squared, divided by x squared plus 2y. And if you wanted to know where your implicit function has horizontal tangent lines, you would set your numerator equal to 0. And if you want to find out where your function has vertical tangent lines, you would set your denominator equal to 0. If you want to find out where your slope is a half, for example, you would set the whole thing equal to a half. Using the skill of chain rule and implicit, we were able to show that inverse derivatives, and so we had inverse and we also had inverse trig. So just generic inverse, we were able to show that if a comma b is on our function, then b comma a is on the inverse by definition of the inverse. And the slopes at those 2 points are reciprocals. So f prime of a is equal to 1 over f inverse prime at b. And notice that these are not the same x-coordinates. They are corresponding x-coordinates. And then we also learned the inverse trig derivatives. So there are 6 inverse trig derivatives. And we derived them, but you don't have to derive them. You can memorize them if you want to. So sine inverse and cosine inverse, we learned all of these derivatives, tangent inverse, cotangent inverse, secant inverse, cosecant inverse, and all of the cos are negative, and so the derivative of sine inverse would be 1 over the square root of 1 minus x squared, and I did that wrong in the video originally, but you've corrected it since then. Cosine would be exactly that, but negative. All of the cos are just negative of what the original one is. So tangent is 1 over 1 plus x squared. Tangent is the nice one because it doesn't matter what order you do things in. Cotangent is the negative of that. Secant is 1 over the absolute value of x times the square root of x squared minus 1. And that's kind of horrible, but at least cosecant is exactly that except for negative. So those are your inverse trig derivatives, super fast. And then from there, we also used implicit to derive the other exponential and logs. So we had the, I'm going to do that down here, the exponential derivative, so a to the x, that derivative is a to the x times natural log of a, and log base a of x, that derivative is 1 over x times the natural log of a. And we derived those, and you can certainly derive them every time, but that's those are probably worth memorizing, depending on how you learn, of course. And then the last thing we did was, well, we combined all of these things. We combined chain and product, but I'm going to leave that off of the map because I feel like that's just something that we did along the way. Then the last thing we did was we did second derivatives. Or I guess it was higher order derivatives. So the big thing about second derivatives and higher order derivatives is that you understand the notation. That f double prime of x just means take another derivative. So take the derivative of the derivative. Or in the other notation, this is the operator. So we're going to do that twice, and that looks like an exponent, but it isn't, of y. Okay, so that's the notation for second derivatives, and then we also did implicit second derivatives. And when you do an implicit second derivative, you just have to make sure that you do substitution for dy dx when you take the second derivative. Sometimes, like, these get horribly ugly, so I would not probably do it for this function because it gets really nasty really fast. But let's say you have dy dx equals x over y, then if you take a second derivative of that, you get low d high minus high d low. Sometimes I write m because I get lazy and don't want to write dy dx all over the square of what's below. So when I rewrite that, I have the second derivative is equal to y minus x over y times x over y, and often that's enough. You can stop right there. Oh, y squared. You can stop right there often, but sometimes you're looking for a multiple choice option, and when you're looking for a multiple choice option, it's unlikely that it would stop right there. They would probably try to get rid of this fraction by multiplying that whole thing by y over y so that you get rid of that fraction. And when you do that, you get y squared minus x squared over y cubed for your second derivative. All right, that is kind of a framework of what we did for Unit 3. So first of all, it's a lot of derivatives that I want you to be comfortable with. You need to be comfortable with all those derivatives. And then it's also understanding really well how to use chain rule and implicit. All right, thank you so much.